let's get into the big topic of open source, something that we actually say at Red Hat. We haven't
This is so
We
awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say
As the
developer
Kubernetes
should-
ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am, as always, your host, Andrew Sullivan. So as the ticker down at the bottom states, you can reach me on social media at Practical Andrew on Twitter, or you can always reach me via email at andrew.sullivan@redhat.com. And as always, I am joined by I'm going to use the word effervescent today, Johnny, because you are very effervescent this morning. My
Man.
effervescent co-host, Johnny Rickard. So good morning
How's
to
it
you, sir.
going? Good morning to you. How are you?
I can't complain. It's another beautiful Red Hat day. So
Indeed.
yeah, it's never a dull moment, and today's topic certainly reflects that. I think it's something that when the blog post and the other stuff was first released about it, was first talked about, there was a tremendous amount of excitement around Microshift and the possibilities of having an OpenShift or an OpenShift-like environment in like very, very small, footprints. So we jumped at the opportunity to have our two guests join us today, Miguel and Ricardo, and we're going to spend some time talking about that today. So I'll hand it off. I'll go to Miguel first, if you don't mind introducing yourself.
Hey, hello. Thank you very much for having us and spreading the word about Microshift. So I'm Miguel. I've been working at Red Hat for 8 years, and this last year I joined the city office, the on the edge team for emerging technologies. And yeah, they were already working on Microshift. I joined them. I have a little bit of a background in networking and also small embedded systems from my past before Red Hat. So everything was aligning. I tend to think that it was lurking in Red Hat, waiting again for the moment for small systems to, now those small systems are much capable than they were.
Yeah. Turns out that edge is something that it's kind of a big deal, right? So I think we're going to see more and more stuff from Red Hat as a whole, and especially OpenShift in that respect. And then Ricardo.
Hello, everyone. First of all, thanks for having us. I joined Red Hat 6 years ago. I come from the telco world. I'm a telecommunications engineer. And about 2 years ago, I joined the Emerging Technologies group in the edge computing team. And about a year ago, something like that, we started to think how we could feed a small Kubernetes and OpenShift into these really small devices, and Microshift was born. So very glad to be here.
Yeah, and it's I think this is the first time that we've had somebody from the office of the CTO on. So welcome to both of you. It's Johnny. We're almost famous now, right?
We're getting there, man. We're slowly climbing the ladder horizontally.
It's YouTube famous, right? YouTube famous.
That's right. We have tens of followers.
Tens of followers. My wife, on the other hand, who is she's I think I said before, she's an exercise instructor. Like everybody around town knows who she is. Like I can't go to the grocery store with her. I can't go to a restaurant without people stopping to say hi. And we just have the internet. We have all of you lovely people.
That doesn't happen to me. So.
All right. So as always, here in Khalid, thank you for joining us so late in the day. I think both of our guests today, you're in Europe, right? I think you're both in Spain, maybe.
Yeah, in Madrid.
Yeah. So thank you both for joining us later in the day for you as well. So I know
if you ever come by, let us know. We will take you out to eat some tapas and good wine.
So you say that.
Don't threaten me with a good time.
Actually, next KubeCon is in Valencia. It's like 3 hours from here. We will be there, but
very cool.
if you have the opportunity, man, we can meet over there.
I tried. My request was not granted, so I will be missing Valencia, or I will be participating virtually, I should say. But
Okay.
I've been to Barcelona many times, and Barcelona is lovely and wonderful, and I would love to see more of the country, but
right,
not this year, anyways. Again, thank you very much to both of you for joining late in your day, and for all of our audience. And so something that's kind of bubbling in the back of Johnny and I's mind is, would it be worthwhile for us to maybe vary times a little bit every once in a while? Maybe once a quarter have something that is closer to midday for EMEA, so early morning for me and earlier morning for Johnny, or maybe even APAC hours, right? So something that's more friendly to the Australia, New Zealand, Japan, China, India time zones. So if anybody has any thoughts or any input on that, please don't hesitate to reach out, especially if you're watching this recorded, because it's not your working hours right now when we're doing this live. Don't hesitate to reach out. Again, social media at Practical Andrew, or email andrew.sullivan@redhat.com, because we'd like to know, right? We want to be accommodating. We want to include everybody as much as we can. And if that means, varying our time zone a little bit, I'm okay with that. So we do have a what I'm going to call a reoccurring segment. I keep saying that as though it's a new thing. Like, I haven't been doing this for 62 episodes now, which we call the top of mind topics. So top of mind topics are things that Johnny and I have found over the last week or so, since the last stream, that we think are going to be important, or things that we want to share with you, our audience. So let's get started with those. And
I actually have the number one top of mind topic that I'm sure everybody on the stream is dying to know about, and it's the picture over your left shoulder.
Oh yeah, I replaced it. It's I've been trying to have a more regular schedule of changing out my artwork. So yesterday was the first day of spring here in the U.S. Well, I guess everywhere spring is the same everywhere, right? So I decided to change out my artwork, and then I won't say I was up late. I was up late for me, like 10:30. Looking at other artwork that I can use in the future. So
I like that one a lot. That's a favorite so far.
Yeah, the business T-Rex, right? So it's very spring-like. So first top of mind topic for today. So Johnny and I got pulled into a conversation with a customer recently. And it was a big conversation, right? I'm using big in air quotes, but it was a big conversation around auto scaling. And, we talked about things like the horizontal and vertical pod autoscalers. We talked about machine and cluster autoscalers. And we happened to have Gaurav, the product manager for scaling in OpenShift, join us. And I learned something new. So we've been asked about, a lot of people have been asking about being able to do cluster scaling based off of custom metrics, or pod scaling rather. And I remember hearing about this like 6 versions ago, and nothing is ever, right? It kind of popped up and then nothing ever came of it. It turns out that there's a whole project for this. KEDA, K-E-D-A. So let me share my screen here real quick. Nope, not add source. Share screen. So the KEDA project, Kubernetes event-driven autoscaling, is exactly what the name implies, right? And you can see down here under scalars, we can set a whole bunch of different sources for metrics to do things like determine when I want to scale up or scale down. So if we come down here, there's like Prometheus, right? I can point it at a one or more Prometheus metrics and say things like, hey, when my web server, shows more than X number of connections per second or responses per second or something like that, scale up. So it's an upstream project now, but I did check the what's new, what's next slides, and it is on the roadmap. So I think it'll be a tech preview feature in one of the next releases. I don't think it's in 4.10. But we do have, and that reminds me that we do have a what's next. So that's a roadmap presentation coming up in early February sometime. I should have checked on this beforehand, but it just now occurred to me.
Early May
Right.
or April?
Early April, yes. I don't know where February came from. I don't. We're well past February, so I don't know what that was all about. So yeah. Anyway, so we do have a what's next, a roadmap presentation coming up. So keep an eye on the stream calendar. So if you are not, subscribed, if you don't have the alerts for the stream coming up, I would also encourage you to go to red.ht/live streaming. And that will have a link to our calendar. So in the calendar there, you can, and I can bring that up actually, red.ht/live stream. It takes us to this lovely page. And if we scroll down here, we have this episode calendar. And I've been trying to do a better job. You can see here, we've got like today's topic in here for episode 62. But if we scroll down through here, you can see all of the other topics that are here. And if you click this little plus down in the corner, you can add that to your calendar. So that way you can see whenever we have streams and stuff like that. And we do try and remove these. Like if we cancel a stream or anything like that, we'll remove them from that calendar. All right. So Kita, interesting. Great news. I'm looking forward to seeing more about this. I think that I'm going to put in a request. Johnny and I will put in a request with Gaurav to see if he can come onto the stream and talk about Kita and the possibilities that are there once we do hit tech preview status with that. So moving on, one of the other things I wanted to talk about, and this came up recently, it actually came up this morning when we were chatting with some other folks internally, which is the question was, what's the difference between a stretch cluster and a cluster that has remote worker nodes? And the reason why I think that came up is because, we have some, I'm not going to say recommendations for or against, but there's some caveats when you're doing a cluster that is stretched. So what does stretched actually mean? And the consensus was more or less that it's a stretched cluster when, and I'm looking for the link at the same time for this KCS. So it's a stretched cluster when we are distributing the control plane nodes across multiple locations. And of course, I'm not logged in. So I just posted the link to this KCS. This KCS has, some guidance, some things to consider, some things to be aware of when you are deploying a cluster, specifically the control plane nodes across multiple sites. Whereas remote worker nodes are where your control plane is in one place, but your worker nodes can be, on the other end of a high latency, low bandwidth link. I think we say 200 milliseconds and 15 megabits or something like that is the, or 10 megabits, something like that is the minimum requirements there. So the reason why I bring this up is because stretch clusters, while they are supported, they can be complex and they don't often meet the needs that you're looking for, which is, most of the time people want high availability. I have, 2 or 3 data centers. I want to spread out my cluster across them. So that way if one data center fails, the cluster, the OpenShift applications keep running. But, my opinion, there's so much that can go wrong there that you often end up with lower total availability of the cluster and the applications because, the lawnmower guy ran over the wrong, sprinkler head and it's caused water to flood into the, the fiber box that's running underground, which caused a short, which caused, the campus link to go down. And now the 2 data centers are isolated, right? So it's one of those, there's a lot of potential for failure. So it just used with caution, I think is where I'll end that with. Johnny, any thoughts?
For sure. No, it's a conversation that comes up a lot with our customers about, disparate environments where they want to put these things everywhere. And I totally agree with you. I don't know if the juice is worth the squeeze.
Yeah. Yeah. And again, anybody who has any thoughts or comments, questions, feel free to post those into chat. So I've got 2 other things here. So 2 hopefully quick things. So one, I happened to stumble across a set of OpenShift checks. So you can see this comes from Red Hat Sysengineering. So This is stuff that was created by Red Hat folks, but it is not officially supported by Red Hat. So you can see here, this is an unofficial tool, right? So it is not a supported thing, but it is created by Red Hat folks. And the goal here is it's a set of things to kind of check and validate whether or not your cluster, the cluster that you've deployed, is working the way it should be out of the box type of thing. So peruse this repo. You can see here, there's a whole bunch of checks down here for things like, amount entropy for doing encryption, and, is there OVN pod port thrashing? Are PVCs that aren't bound, blah, 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 right? There lots of stuff inside of here. I know we've had a lot of folks ask about, is there something I can use to check the health or the status of my OpenShift cluster aside from the console, the overview, right? With green light, red light type stuff. So this is one way that you can potentially do that. And I want to make sure that we share this link. And where is there we go, Twitch window. I just posted.
My bad, Andrew. Sorry.
No, you're good.
I was just going to give Matthias some props for his acronym there, the Stoneth acronym.
I'm not familiar with that one.
Shoot the other node in the head. It's a fencing acronym, yeah. Go blast it.
All right. Last one for me, very quickly. So OpenShift 4.10, the bits shipped, I don't know, 2 weeks ago, something like that. But marketing being marketing, they didn't release all of the press releases, blog posts, all that other stuff until yesterday. So even though you've had access to the bits for at least a week, if you were to look at cloud.redhat.com today, you'll see a number of blog posts that talked about all the stuff that's in 4.10. So I'll link this blog post. I'll also include in our blog post, the one that we follow up with here. Where's the right window? Links to the other episodes, the other streams that we've done on OpenShift 4.10. And then, so that's the last top of mind topic I had. Johnny, you had one or two, I think.
Yeah, I have two quick ones. The first one is just kind of a continuation from our conversation last week with the service mesh. A good friend of mine, Kat, and her cohort, Kat Cosgrove from Pulumi, did a live stream on IAC for Kong using Pulumi. Pulumi is a lot like, I don't want to say it's Terraform, but it's an IAC tool like Terraform, but it's more from like a programmer's perspective. So you can use different languages like, Go, Python, whatever. And you can, completely configure a deployment. So I'm posting the link here if you don't mind sharing that link. If you guys just go check it out. And then, Pulumi seems like a pretty cool tool. Both the cats had a good time doing it. It was a pretty good presentation. So go check it out if you have some time. And then the last one is Ansible Automates is tomorrow. It's a free event that Red Hat puts on. The link should be popping up pretty soon here. So if you get some time, go check out what's going on with Ansible, and hopefully you learn. That's it.
Don't mind me. I'm just trying not to sneeze into my microphone over here.
Bless you.
Yeah. What's the thing? Normally you're supposed to look at the sun or something, and it makes you sneeze. Anyways.
Or you try and call it out before it happens to ruin it.
Yeah. So, and I'm just realizing that it's kind of dark in this room too. It's cloudy outside today. Yeah. Storms later today. All the weather that was coming through Texas yesterday or the day before is coming through North Carolina now.
Yeah, we got lucky. It went right over us, man. It hit just north of us really hard. So,
all right. Well, so today's topic. So as we started the stream with today, our topic is Microshift. And Stephen Reeves, I see your comment there about multi-node and some other things. So I wanted to kick this off by handing over to Ricardo and Miguel to talk about, kind of one, what is Microshift? What makes Microshift and not OpenShift? And, kind of go from there and talk about use cases, where we think or where we expect people will be using it. And very much to your point there, Stephen, I'm interested in using it in my home lab too. So let's see how appropriate that is.
Okay, I can start. We've prepared a couple of slides. I think I will share them and go through them very quickly. And it's better to have interactions and questions and more informal kind of session. Let me
Yeah, the audience is not shy. They
I can see that.
So anybody who has any questions about today's topic or about anything OpenShift related, please feel free to put those into the chat. We'll address those and get your questions answered.
Let me know if you see my screen.
Yep, looks good.
Okay, so I have a couple of tabs here. Let's go through the presentation. It's, just very quickly. Okay, so what's Microshift, right? There you go. So, edge computing is been a topic for some years right now, and inside Red Hat we've built OpenShift, which is an awesome product. It's capable of doing a lot of stuff. It's amazing, how many features it has and so on. But OpenShift has been designed from the beginning for the data center, right? For creating an on-prem cloud or deployed remotely, but basically it provides cloud native capabilities. Then for edge computing, Red Hat has launched Red for Edge. Red for Edge is basically our RHEL version with RPM OS3, let's say, a structure. And the goal is to deploy applications using Podman, containerized applications using Podman. So the thing is, what if we want to use in these edge computing use cases, in these edge computing scenarios, what if we want to use Kubernetes applications, the same applications that we have designed or built for OpenShift? And this is where Microshift started. We created Microshift to fill that gap in the middle. So then, what is Microshift? Is a small form factor OpenShift optimized for field deploy devices. We will explain later what we mean about field deploy devices. What are these devices? And what we wanted is to provide a minimal OpenShift experience. So the goal basically is to be able to run something like OpenShift in very small devices. We can deploy applications. Sorry, is there a question?
Yeah, so there's actually a couple of questions that when you feel like you're at a good pausing points, we can ask those.
Yeah, it can be now if you want.
So I wanted to make a couple of comments, and then there's a couple of questions. So one, RHEL for Edge is really interesting to me. I've done a little bit of investigating and playing with it, and it kind of reminds me of what we used to call Atomic, right? It's RPM OS3 based. It's really optimized for containers. And I saw a really interesting demo recently of using OpenShift pipelines to build an application and do things like, use ACS to do container image scanning and all of that other stuff, and then push that to a registry, and then use Ansible automation platform to push that out to RHEL for Edge nodes, and have it run on or via Podman out at those nodes. So I thought that was really interesting and kind of a very much to your point here of it's RHEL, so you're managing it in the RHEL way as opposed to OpenShift or Kubernetes, where you're managing it in the Kubernetes way, which is, I think, the primary difference between, RHEL for Edge and Microshift.
Right.
So questions. So Sean asks, what do you mean when you say edge computing? I think we use that term pretty broadly. So maybe we can be or clarify or maybe be a little more precise.
Yeah. It's really difficult to be more precise because edge computing is a very loaded word, and it can mean a different thing for a different person. So
maybe I can take this one. I was trying to write something today to explain what edge means to people who is not familiar with it. So it's and please, Ricardo, extend or correct, because as you said, it can mean different things to different people. But it's an architecture of how do you design and deploy your applications. It means that you are going to put the computing power and sometimes storage as close to the source of that data or the consumer of that data as you can, maybe on the same network or the same area. This is useful for many things, like, for example, vehicles, farming, entertainment, cameras for surveillance. Ricardo and I did a small demo with Microshift. Maybe we can share the link later. Anything where you can deploy applications to be very close to the consumer or the user is the edge in the end.
Yeah, and I think it's hard to narrow down because the use cases are almost unlimited, right? Because I mean, you can consider, a retail scenario, right, where I'll pick any big box retail store, Walmart, Target, etc. If they have IT resources in the stores, you could consider that edge. The same thing with like restaurants, right? McDonald's, if they have IT resources in those stores, you could consider that an edge. I think one that a lot of people don't think about is things like the electronic billboard signs that we see here in the US on the side of the highway. Like, those are edge devices, right? So it's really almost unlimited different use cases.
Yeah, I mean, even on a store, you could go and deploy your applications on the digital scales that you have, where you're going to put your fruit, your whatever you're buying. I mean, almost anything close to the user.
Yeah, so something I like to think about is, for the past, 15 years, the IT industry has been trying to centralize everything, right? To put everything in data centers and create big warehouses with servers, with thousands of servers and so on. And then we've realized that the more devices are connected to the internet, the more data we produce, and that is very expensive to send all this data through the wire, to the central locations. Mm-hmm. So we need to start putting computing power next to where the data is created, and that can be an autonomous car, a 5G antenna, a retail store, things like this. So, it's basically trying to reduce the data that you send over the wire, and process that data before.
Yeah. Some very cool examples that I've seen lately are like, recently I went in a taxi and they had like a small device with ads for the people on the taxi, and as you came into the taxi, there was a warning like for GDPR, like explaining that they are collecting data on the ad viewers. Like there is an AA model that on that computer is going to identify, if you are, like your gender, characteristics of you, and which ads are you paying attention to. Mm-hmm. So that's a very clear example.
Seems like advertising drives a lot of innovations in our industry these days. So there's a slew of questions that I'm going to lump into one, and they're all kind of around is Microshift a replacement or an equivalent to things like micro Kubernetes or micro K8s, or let's see, what's the other one? Help me out here, Johnny.
Minikube and like CRC.
Minikube, yeah, CRC, so on and so forth. Frostmageddon here. Is it Frostmageddon? And I'm losing track of my chat here. Frostmageddon, what's the difference between Okd and Microshift, right? Okd is the upstream version of OpenShift, so it's a full OpenShift in that respect. So I think we're getting ready to answer those questions in the slides that you had up.
Sure. We have designed Microshift with the goal of fulfilling the edge computing use cases that we have in mind. That Minikube, microcates, and so on. The first idea, it's more like a development environment, or for your home lab, or to get some Kubernetes in a resource constrained environment. That Microshift can do as well, but our main goal, it's been always edge computing. Mm-hmm. Let me finish very quickly the slides. Microshift as well as OpenShift can be managed by ACM, Advanced Cluster Manager. And the way that we have built Microshift is basically a single binary that contains all the control plane, the Kubernetes control plane, OpenShift APIs, kubelet, kubeproxy, all the components in a single binary. Then and we will see it in the demo, when you start Microshift, there will be some extra services that will be deployed, like Ingress, CNI plugin, and so on, that makes your life easier. But basically, it's just a single binary. And we have different deployment models. It's an RPM package or container image. And we have an extra, which is an all-in-one container image that contains our CRI-O, the container runtime. So it can also work in macOS, Windows, and so on. We've built Microshift in different architectures, basically x86 and ARM, but also RISC-V and PowerPC, and so on. So field deployed devices are basically the typical systems on chip that are very different from servers, right? These small devices usually have very unstable network connectivity, or they have none. Usually they're like headless devices. There is no screen or keyboard to access. They are, in theory, so cheap that if one of them breaks, we will have to replace them and not trying to fix them. And yeah, everybody knows the Raspberry Pi, right? And now NVIDIA has the Jetson family, which are small platforms and provide some capabilities. They have I2C buses to connect to, for example, server controllers, SPI, cameras via CSI. There are a bunch of interfaces and devices that can be used from these platforms. I don't know, Miguel is our embedded systems expert. If you want to add something here.
No, I think all you said makes a lot of sense.
Okay. Well, this is the deployment workflow that we picture to deploy Microshift, but let's compare Microshift with OpenShift. This is one of the questions I see in the chat. So in the left side, we have OpenShift. And the way OpenShift has been designed is that it's like a whole stack. So we have Railcore OS as the operating system, and it's a fundamental part of OpenShift in the end. Then we have Kubernetes plus the OpenShift APIs that we provide. And we have a bunch of cluster operators that will manage the cluster. From, for example, the cluster version operator that will manage the versions of the operating system and the components, the machine API operator that can manage the infrastructure itself that is underlying OpenShift. You are OpenShift admins, so you know this much better than me. And then on top, we will deploy Kubernetes applications and OpenShift applications. Mm-hmm. Microshift has been designed to be completely decoupled from the operating system, and we want to treat it as another application, right? As another RPM package in our operating system, or as another container running on it. We like to use RHEL4Edge as the operating system, but of course it's not mandatory. We can use it in anywhere where we have a container runtime, and we can deploy containerized applications as well.
So a couple of things here. So one observation for me is this kind of goes back to the model that we had with OpenShift 3, right? Of the underlying operating system and its management is decoupled from the microshift management, right? So in this model, you don't have machine config operator, for example, that's going in and pushing down, a RHEL4Edge RPM OS tree updates. Instead, you would manage that operating system the way that you always have. You just have that microshift, OpenShift API on top to deploy and manage your applications.
That's correct.
Okay.
Yeah.
Okay.
Yeah.
So there's a handful of questions here. So Alan asks, is there an upstream version of Microshift, right? Is it still OKD or is there something different?
Microshift is an open source project. It's not let's say a product. Our goal is to get it productized, but so far it's just a project that from the office of the CTO we launched. And if you let me go here, just there are too much information here. But if you look at how we built Microshift, basically we are pulling the objects from Okd. So Okd is, as you mentioned, the upstream version of OpenShift, and since Microshift is an open source and upstream project so far, we've pulled versions from Okd. So every component that is embedded in the Microshift binary, all the extra services that are running as pods, scheduled pods, are also container images pulled from the Okd repositories. So the latest version of Microshift is pointing at 4.8 Okd, and we are working on the rebase to 4.10. I mean, a rebase shouldn't take too long to perform, but we had other priorities, and for us it was better just to keep one stable version and try to add more functionality to Microshift.
Mm-hmm. And Khalid asks whether or not we can deploy operators to Microshift.
Microshift does not provide cluster operators, but we can deploy operators on top. So we've tried, for example, Submariner. We've tried CMV, KubeVirt. We've tried, there are plenty of operators that you can deploy. You can even deploy OLM in case you want to have the catalog and so on, and deploy from OLM the application operators, let's say.
Yeah, and I know Christian Hernandez was, he and I were chatting about that a week or two ago because he wanted to deploy the GitOps operator and needed OLM before he could do that.
Yeah, he's very active in the Slack channel. We have, it's everything in the website, but we have a Slack channel. Everybody is invited there in case, you have questions and so on. So.
Yeah, I'm not going to give Christian a hard time this week. He's on PTO, so I usually only do it when he's here. And I know he shouldn't be listening this week because he better be on and enjoying his PTO.
Yeah, he needs it.
Yeah. So I also saw Thomas Hall asked about what is the recommended tooling for managing the underlying operating system and hardware with Microshift. And Miguel, I think that was something you were gonna address.
Yeah. So we are working on the. I mean, along with Microshift, we are working on the whole end-to-end history about how to manage devices on the edge. So, I mean, our goal for Microshift was edge devices. So edge devices, normally you manufacture them, you configure them, and then you put them on the field, or a variation of this. Or you put them on the field, and as you put them on the field, they are going to configure the way you wanted them to be. So this is one of the reasons why we are building on Rail4Edge, because it uses OS3, and with OS3 it's very easy to get your device connected to an OS3 repository and get atomic updates of your operating system. That operating system could be an image that contains the Rail4Edge minimal tools, Microshift, and even if your device is not going to have like a very stable connection, or you want to pre-configure the device before you send it into the field, you could even, I mean, we are developing the mechanisms to embed the container images into the OS3 image. So as soon as you boot, you have Microshift, the container images, your end applications in container images too, and the deployment details for your application. So Microshift boots, so Rail4Edge boots, Microshift boots inside Rail4Edge, and your applications start inside Microshift. So we are trying to define the whole end-to-end deployment story around that. But I mean, there are many pieces. Like you could manage then the applications via something like ACM. We are also looking for scaling that. So as you know, ACM was designed to handle lots of clusters, but maybe in the edge use cases, we are looking into the thousands or hundreds of thousands of devices, and we need to make that scale. But yeah, we are mostly designing around managing everything via the OS3 in Rail4Edge, ACM, and
yeah. And I'm thinking back to the What's New in OpenShift 4.10 presentation, where we announced to the world that we're working with OEMs to pre-install OpenShift onto hardware. And so very much like what you have in that upper left hand block there, put Microshift on there and ship it out and turn it on, and it can connect up to the world and fall underneath management automatically. And that very much that hundreds of thousands of nodes thing.
That's right. And with Image Builder, you can create your own customized version of Rail4Edge, right? You can build Rail4Edge with, for example, Cryo in it in the RPM OS3. If you want to include also Microshift, you would be able to do that. And then once you have your image, you can send it to your manufacturer. It will be imaged into 2,000 devices and sent to the remote locations. And once you connect them, it will be all automatic. So if you want, we can do the demo very quickly, and I'm sure there will be more questions.
Yeah, please. There's a ton of questions. Everybody's very curious.
Just for everybody, we have a website called microshift.io, and the GitHub repo is in the Red Hat ET organization, Emerging Technologies, and it's a public repo, so you can open issues, not too many, pull requests, and have a look at the code. Let me open the terminal. Okay, so I've created a Fedora, a Vagrant Fedora VM. And what I'm going to do you see both sides? Yes?
Yes.
Okay. So I'm going to follow the official documentation to see that it's working. We have, as mentioned, two different ways of deployment, RPM-based and container image-based. Let's do the RPM-based, which is, let's say, the easiest. First of all, we need to install Cryo. Let's do that. And I have to install as well Firewall D, because I don't think in Vagrant it comes by default.
So while we're waiting for that, I do have a quick question. Is
Sure.
Microshift, are we intending to submit that to CNCF, or is it like since it's a derivative of OpenShift, it's already there?
I don't think we've planned to push it to CNCF. Like as a personal opinion, I don't know if it makes sense to have distributions in CNCF because it's the core components are basically the same. It's just a matter of how you package them, and for Microshift, I don't think so far it's in our plans. Let's say. Sorry.
Yeah, in the end, it's a version of OpenShift or Okd.
Yeah, that was my thought. Is because OpenShift is already a CNCF certified Kubernetes. I would think that it inherits maybe, but I don't know the processes or the requirements there. So it's an interesting question.
So here we are enabling the Copper repo where we store the Microshift RPMs. We are installing Microshift, adding some firewall rules to open some ports, and launching Microshift, basically. The RPM package deploys a systemd service, and once Microshift is up and running, you will see the logs in the journal and so on. It's like another application, right?
So Khalid asks if we can add a rel for edge node to an existing OpenShift cluster, and I believe the answer there is no. So OpenShift proper only supports full rel 8 nodes as of OpenShift 4.10. OpenShift 4.9 will support rel 8 or rel 7, although it's rel 7 is deprecated, and then OpenShift 4.8 and below only support rel 7 compute nodes. So I don't think rel for edge is a supported operating system for OpenShift itself.
Sorry, I forgot to start firewalling.
I appreciate that you have a mechanical keyboard. I have one as well.
I know. I wanted to say something. I was biting my tongue on it though. Thank you, Andrew.
Too loud?
No, it's amazing.
No, it's perfect.
Okay. It's just the cherry red. It's not too clicky, but I love the feeling.
Yep. Yeah, Mike Murphy. Pies are hard to come by. Yeah. Thank you, global chip shortage, pandemic, supply chain issues, all that other nonsense. I've been trying to get some for months for various reasons, and just I've been unable to without paying exorbitant prices that I'm unwilling to pay.
So we see the systemd service that Microshift is running. We will just install the OC client and kubectl, and well, I'm going to show the journal, but it's too crowded, let's say. Journals.
So is there anything that keeps us from working in a disconnected or air-gapped environment? It should be just downloading the binaries and then pulling the images over, right?
Yeah.
Yeah. So for disconnected environments, I mean, you need to put the container images that we use into the system. So it's not on the repository yet. We need to finish a few things because it was a complex thing. But we managed to package the container images into another RPM. So if you want, you can install that RPM, and it's going to go to Cryo and configure like a local read-only storage for those containers, and then there is no more download that needs to happen. You can just install Microshift, install the package with the containers, and then it's completely, it could run completely offline.
Mm-hmm.
Gotcha.
So, sorry, go ahead.
No, you're good. Go ahead.
Just to mention, when Microshift starts, the RPM version of Microshift, it will create a folder in /var/lib Microshift. And there you have all the resources, all the kubeconfig files, certificates, configuration for each of the components, and so on. And the way that the user interacts with Microshift is basically using the kubeconfig file for the kubeadmin user. So we've copied it to the default location, and here in varlib Microshift, you can see all these resources, let's say. It takes a little bit to download the images, but I think everything is up and running. After 2 minutes, Microshift, you install the RPM, you start the service, and after 2 minutes, these extra services are already up and running.
Yeah, one note about the images that we use at least for the Intel platform today, those are just the Okd images. So we don't reveal them. Those images are already tested, and it's an advantage. For ARM platforms, I think we don't have ARM64 yet, for example, in Okd. I think it's something that is being worked out. So we build our own images for that. And something that I've noticed is that the images that we managed to build are much smaller than the ones from OpenShift. So I was thinking about providing some feedback about how to hopefully optimize those images. It would mean removing things that are on the system that I don't know. I mean, maybe there are technical reasons for that to be there, but I think that we could use that feedback to improve the size of the OpenShift images.
So Khalid asks another question. What's the difference between Microshift and simply using Podman on the hosts? And I think the answer, or I think why that might be slightly confusing, is because if I remember correctly, Podman, you can output what are effectively unit files that look like, a Kubernetes pod definition and have it interpret that.
Yeah, no, I think that his question is more, what is the difference between the deployment model that Ricardo was following and the deployment model where you deploy Microshift with Podman, where you
got it. Okay.
You have.
Yeah, so we have these two different deployment models. One of them has some advantages and disadvantages and so on. For example, we have always in mind the edge computing use case. So in case of Rail4Edge, you have, you install Image Builder and you want to create your own Rail4Edge customized version of Rail4Edge, right? And you will include in the RPM OS 3, you will include Cryo, for example. And then you have two options. You have the option of including as an RPM Microshift, or you will deploy Podman on top of Rail4Edge. What are the benefits of, for example, running Microshift as a container? In case that we want to upgrade Microshift without impacting the workloads that are running our applications, it's just as simple as creating a new tag, like upgrade a container. That will not have any impact on the applications that are running on Microshift, because in the end, they are running on top of Cryo. In case you want to have everything included in the RPM OS 3, you will use the RPM to have an immutable operating system. And when you upgrade the whole OS 3, you will have to reboot. That will have some workload downtime, right? So it depends on how you want to deploy your devices and manage your devices.
Well, I'm glad that you corrected me on that one, Miguel, because I definitely misunderstood that question. So thank you. There's a question from before, and my apologies, I don't remember who asked it, about multi-node cluster support.
Right now, it's only single node. We have a PR ongoing for multi-node, starting with adding new worker nodes, but it's not finished yet. So I would say it's work in progress.
Yeah, it's functional, but I mean, we are talking to other teams, and we are trying to figure out what is the best way to do it in a way that we don't change how security works in OpenShift. So everything that is already validated for OpenShift will be validated also for Microshift.
Mm-hmm.
Right.
That makes sense. You don't want to have to redo work.
Yeah, especially around security.
And there's another question from Mike Murphy about essentially he was asking, like, once you have the Microshift up, realistic or theoretically you could use an internal registry if you wanted to, right? Like I'm assuming he's talking from another like OC cluster, but like if you wanted to run a registry on Microshift, it's essentially just running either, you know, like the Docker registry and then exposing it that way, or, you know, just any other deployment type for a registry, right?
Right. Any image that you can load into Cryo, for example, you will be able to use it from Microshift. So,
gotcha. And then the way that you upload images now, because it doesn't have a registry, right? Like it would either go directly into the binary, or you would just stand something up on the outside and let it pull it into the runtime, right?
Yeah, for the components that are embedded into the binary, we basically use the libraries. We don't pull any image from anywhere. It's basically using you know, from the binary, from a central service manager that we have implemented. You will use the different versions of the components. It's basically using Go modules and so on. And for the infra services that you can see here that are running, we point at certain tags from Okd images, and for the disconnected environment, we package those images into an RPM, and that's basically it.
Yeah, I shared the link to our image repository. But if you, I mean, in there we create like multi-architecture tags for the images. But if you deploy Microshift on an Intel platform and you look at the pods, you will notice that we are not using that repository. We are just using the Okd image tags from the Okd repository.
Gotcha.
Because we wanted to make it, even for the Intel version in this repository, we just clone the image from Okd, but we wanted to make it very clear that we are not rebuilding them. We are using the ones already built and tested.
Yeah.
Gotcha. Awesome. Thank you.
Let me continue with the demo because it takes a while to download some of the components. But so we have an OpenShift instance running in our lab, and it has ACM, the Advanced Cluster Manager. What we're going to do is basically go to clusters and import a new cluster, which is Microshift. We haven't done any work on ACM as such in terms of identifying that this cluster is a Microshift cluster and so on, but it works anyway. So we go to import cluster, let's say Microshift device, for example, and yeah, we generate the command. We copy the command here, and we execute it. It will deploy. It will install the CRDs and basically the clusterlet, which is the agent from ACM that will allow the communication and the management from ACM. So we can
awesome.
And once it joins ACM, it's just like any other cluster. So any tags that exist to have it, you know, things deployed to it automatically, all of that other stuff applies just the same.
Of course, there are some constraints, because, for example, if we don't have the cluster version operator, ACM will not be able to upgrade the cluster. Or if we don't have the machine API operator, we will not manage the infrastructure that is below. But in terms of policies, applications, and that all works or should work.
Yeah, I mean, something important to keep in mind is that if you are managing applications that run on different architectures, you will need to provide images for those architectures, or images which are multi-architecture.
Mm-hmm. And I would assume the limitations that you were just describing, Ricardo, are going to apply to any Kubernetes or any non-OpenShift Kubernetes that is managed by ACM as well.
Yeah, that's correct. That's correct.
Yeah.
So now it will try to install. So we have the clusterlet running. ACM has recognized Microshift as an imported cluster. Now some add-ons will be deployed. This takes a little bit, but we can continue with creating our own applications. And once the cluster is fully imported, let's say, or with all the add-ons and so on, it will apply and install our application. Mm-hmm. Let me remove some tags that maybe we don't need here. For example, the AIM certi policy control. Okay, let's keep it like this. This as many add-ons as we add, there will be less room for applications, right? So I don't know if the add-on controller is not yet there, but let's go to the applications tab in ACM, applications, and I'm gonna install a very simple application. It's an Nginx with a service. We create application, subscription. If I go too fast, let me know. And if you have questions later, you can always address them.
Alan did just slightly tangential. Alan did just ask a good question, which is there an upstream version of ACM? Like, is there an Okd equivalent to ACM? The answer to that is yes. I recently learned this myself. It's open-cluster-management.io. So it doesn't have all of the GUI stuff, right? Because that's what they that's all the Red Hat stuff that they add on, but all of the functionality, all of the stuff that you do through the Kubernetes API, because remember, everything is just a Kubernetes CRD inside of there. All of that stuff is there. So I found that out. I was working with Jimmy Alvarez recently and found that out. So one thing that's interesting to me is, you're using, OC-get pods and other OC commands here. Can you, like, from the host, if you were to do just a podman PS, would you see all of those containers running there, or is it through, Creo or something like that? So would you use cry control?
Yeah, it's basic. I didn't install cryctl. It's basically running on Cryo. Let me install CryTools. Is it like this?
Sure.
So it's very much like OpenShift, right? If you were to debug to an OpenShift, a CoreOS node, and if you do a sudo or su over to root, you can use cryctl, crycontrol, and just like we see here, see all of the container images that are running inside of there. So that's really cool.
Yeah, the container runtime is the same as OpenShift, and we can use the same tools, let's say.
Which also means that you can do troubleshooting and stuff like that by looking at pod logs directly through, or container logs directly through cry control.
Right.
It kind of came up earlier in like the conversation, right, about using the same workflow and same tooling from the IoT device or the edge device back to your cluster and stuff like that. And I think that that's probably one of the biggest things that, like, when we were talking about this early on with some of our customers, is like that workflow is going to be very similar using Microshift as it would be like using OC, right? Like the same thing you're talking about, like debugging pods or debugging containers using the OC command line and APIs and stuff like that. This is super exciting.
So what we have done here is basically to create an application. The application is very simple. Let me show it here. It's just a deployment. The image is an Nginx, and we use a service to expose a node port service to expose the application. Mm-hmm. Here, ACM through the wizard or the GUI, it creates the subscription and the placement rules. I've clicked on deployed on all online clusters. So this is the placement rule. And it will take a little bit until Microshift is detected as up and running and fully imported. And then it will deploy the application. Let's see how it goes.
What's the worst that happens? It can't be any worse than Johnny's demos. So is there the equivalent of an admin console or a developer console with Microshift, or is it all CLI / ACM?
It's all CLI. Yeah, one of our design constraints was basically to, not to bloat the binary and not to make it very big. Mm-hmm. And of course, that comes with the problem of not having some functionality. So no console, it's only CLI or ACM.
Frostmageddon. All I see right now is the dollar signs. We'll need to upgrade Switch and obtain a bunch of new pies for a mega cluster. So that does ask or bring up a couple of interesting questions. And Frostmageddon, I think you asked earlier. So one, is there, when multi-node becomes a thing, will we follow the same control plane requirement, node count requirements that OpenShift does? So, 1 or 3, or can we have 5 or 7 or 9? And then also, is there like a minimum requirements for Microshift? Like, can I use a Raspberry Pi with, 2 gigs of RAM? Do I need to use a Pi 4 with 8 gigs of RAM? That type of stuff.
In terms of requirements, our goal was to fit it into 1 CPU and 1 gig of memory. So, for example, with 2 gigs of memory, and 2 CPUs, it would be enough.
Everything beyond that is for applications.
Yeah.
Got it.
And for the operating system, yeah.
Yeah, that's refreshingly lightweight, of course, compared to things like code-ready containers and single-node OpenShift.
Look, the Edge application that we created in ACM is now getting deployed. I forgot to answer the other question about control plane requirements. We want to follow and to have the users the same, and admins the same experience as OpenShift. So we will follow the same patterns in terms of only 1 or 3, and that's the goal.
Yeah, we've talked about before here on the stream how going beyond 3 control plane nodes is often a counterintuitive anti-pattern because you add so much complexity that it can make things more fragile. Mike Murphy, is there a recommended operating system when running in, for example, a Raspberry Pi? So I don't, is a Red Hat operating system or Red Hat derivative operating system, so Fedora, Rail for Edge, et cetera, is that a requirement, or can you do things like, what is the name of the Raspberry Pi operating system? It's Debian based, whatever it is.
Raspberry. Yeah, Raspberry. Yeah.
Of course, an RPM won't work on those environments, but you can download the code and compile it. And if Cryo is installed, it would work. Also, the container image would work if you can deploy it on Docker, for example. In the main website, there is also what we call an application development Microshift deployment model, which is this all-in-one image. So you can deploy a container in your Mac OS or Windows, and it will have Microshift plus Cryo plus all the dependencies. So we support only Red Hat-like operating systems, but you can deploy it, I think.
Yeah, mostly because sometimes you depend on things which are going to be on the kernel, like specific IP table versions or NF tables, and sometimes we found that it was non-stable if you don't have a little bit of control over that. But I mean, you can do it. It will work, as Ricardo said.
Mm-hmm. So I think we're probably coming up towards the end of our time. So I just want to go ahead.
The cherry on the top of the pie. The application has been deployed, so it's let's access the service. It's just an Nginx, so nothing fancy. But the IP of the device, like the host IP, is this one, and the port is 30303. 30303.
Well, so to be clear, I work for y'all for the next however long you want to be on the stream. So I want to be respectful of your evenings. I know it's getting kind of late in the day for you. So I don't want to eat into too much of that time. So for our audience, if you have any questions or anything like that, please feel free to submit those in. We'll do our best to address all of those and try and keep to a reasonable time. I see we've got a few pending questions as well, and I see that our application deployed successfully, which is amazing. I love it when it works exactly the way that we intend it to and the way that it's supposed to, right? Yeah. Well, it's so funny, right? Because I've been recently having some conversations with folks around, like, should we expect or be surprised when Kubernetes works the way it's supposed to, right? It's a 7-year-old project, or Kubernetes 1.0 was May of 2015, I think. So, it's 7+ years that it's been around, and sometimes it still feels like people are surprised when Kubernetes does exactly what it is supposed to do. Like, no, we shouldn't be surprised. That's what we should expect. So a couple of questions in here. Let's see. So Felipe, I know we're talking about Microshift, but can I use single node OpenShift for Edge? Yes, you absolutely can. So the big difference there is single node OpenShift is going to be a quote unquote full OpenShift, right? It's going to have things like the metric service and operator lifecycle manager and machine config and all of those other things inside of there. Whereas Microshift, and please correct me if I'm wrong, Microshift is really targeted at providing that OpenShift API for deploying, containerized applications to those ultra low resource edge devices. Doesn't have to be ultra low resource, but that's one of the goals. So it doesn't have a lot of those other things, and it may make sense for a lot of different use cases. Install Podman on your MacBook. I don't. They're still working out kinks with Podman on the M1.
It works. It works. I've used it. Yeah, you can do Podman machine and then deploy pods.
Okay.
Yeah, we have an issue with Microshift there, which I am trying to investigate because of the amounts of the container volumes. But yeah, it should work.
All right, I'm gonna have to try it again then, and especially since now I'm thinking of, so if Microshift already natively runs on ARM, can I run Microshift on my laptop to then be able to deploy things? that could get interesting. Matthias, is SE Linux a requirement?
Not really. I mean, you can disable it and it will work. We wanted to have security in mind when we built Microshift, so we have all the policies, and there is an RPM package that installs all these policies, but it's not a requirement. Nor firewall-D as well.
Got it. I don't know if anybody else can hear the very loud vacuum truck going by my house. It's good. It's that time of year where they go around and vacuum up all the lawn clippings, etc. Yeah, so I don't see any. Johnny, keep me honest here. Do we have any other
So
unanswered questions?
Khalid was asking, or Khalid was saying he would love it if CRC and Minishift made babies and had like a lightweight CRC. That's my wording, not his, but like basically he wants to see CRC and Minishift or Microshift kind of like conjoined and then have like a lightweight CRC where you have like, I'm assuming because you get the GUI and all that stuff that comes with CRC. And then there was one more. Oh, and this was from Alan where he was saying, he knows it was mentioned earlier about it not being an official product, but like, what's the roadmap for Microshift?
The roadmap in terms of the community project, let's say.
Yeah, or like where essentially like where Microshift fits in the Red Hat product line eventually. Like if we can talk about it, if not, then obviously.
Yeah, the goal is to get it productized. We are not there yet. And in terms of roadmap, for example, multi-node is one of the PRs that we have open. We are trying to stabilize it as much as possible, rebase it to 4.10, OKD 4.10, and get better support for different use cases. For example, Miguel, if you can copy the DevConf YouTube video that we have, we did this demo about AI at the edge, where we use Microshift in one of these NVIDIA Jetson boards. And there we deployed Microshift and a face recognition application on top. And we used really low-end equipment with $5 cameras, ESP cameras, and the NVIDIA Jetson board. So this type of use cases that will be, in the real world, and these kind of boards will be used in autonomous cars, in drones, in whatever. We are trying to get Microshift in a better shape for those.
I think you just inadvertently answered another question that I had skipped over from Steven, which is can Microshift access host devices, storage GPUs, etc., from example from a Jetson?
Yes, it can. We have deployed. I mean, regarding the Jetson family, there is this what it's called NVIDIA Container Runtime that you hooked up to Cryo, and then you can access the GPU, the integrated GPUs. And we have also tried in a discrete GPU environment where you have the cards to install the GPU operator, the same as in OpenShift. And the device plugin will take the GPU device and the workload can see it. We have tested that.
Yeah, but just keep in mind that, there are still no NVIDIA drivers in Fedora, for example. So in our testing, we were using Linux, the Linux for Tegra distribution that NVIDIA builds with their own kernel and so on. And then we used non-containerized Microshift inside because we need to use the NVIDIA container runtime. So one option could have been using the Microshift all-in-one, but that means that you have the container runtime inside the container, and then you don't use the container runtime on the host, which is going to be the NVIDIA one. So yeah, it's we did it by installing the Microshift binary, but probably if you install Cryo and then on the Linux for Tegra, and then you install the Microshift container, not the all-in-one, just the Microshift container, it should theoretically work. Otherwise, the binary works. Mm-hmm. And we know that NVIDIA is working to have full support for upstream kernels.
So I have one last question for you, Miguel. So the flashing lights there to your right, is that your home lab? Do you have like a little cluster of Microshift running there?
No, that's just an aquarium.
Oh,
yeah, it's actually up here, but it's very messy. Maybe I can move the camera around if you are not.
It's a home lab. It's supposed to be messy.
If you don't get too scared, Like I have Raspberry Pi here, and the logic analyzer is out now, and I have more.
Oh, that's great.
I love the gopher. That's awesome.
Do you want to talk about your smart fishes?
Smart fishes is. I feel like that's one of those. Gosh, when was it that I think it was DockerCon? They had the thing with Kubernetes objects in Minecraft, where like when it like imported all of the Kubernetes objects into different animals. I was just having a conversation about that with somebody the other day. So I'm thinking smart fishes were like the fish swimming around doing some some image analysis, some AI ML there to have it do certain things. But anyways, I won't for our audience, if you have any questions, if there's anything we didn't get answered, if there's anything that comes up, if you're not watching this live, please don't hesitate to reach out to us. So you can reach me at Practical Andrew on social media, so Twitter, Reddit, all of the things. I have basically the same username, and of course email as well, andrew.sullivan@redhat.com. And Johnny is Johnny, Jonny at redhat.com. And JRockTX1. Did I get it right, Johnny? Yes. And it's only taken like 20 shows for us, together for me to remember that.
Never too late, man. It's never too late.
So thank you so much for joining us, Miguel and Ricardo. This has been really phenomenal, and it has really gotten me excited about a lot of things I can do in my home lab. And my wife is going to be upset because I'm probably going to accelerate my purchasing plans for some Raspberry Pis. So yeah, this has been really great. I've learned a lot today.
Microshift will be a great reason for divorce. So
I don't want to take it that far.
I like where your head's at, though. I like where your head's at.
It was in our main goal was to split people.
Yeah, once it gets productized, then I can justify it as a work expense, right? Then I can. I got to run it in AWS. We'll just charge, see if I can submit an expense report or something.
Right.
So
thank you very much for having us.
Yeah, thank you. And
thank you.
You all are welcome anytime. If there's anything that you ever want to talk about on the stream, I know everybody would love to hear from you. So for our audience, thank you for joining us today. We will be back next week. I don't think we know what our topic is yet, Johnny. Stephanie is behind the scenes, shaking her fist at us because we haven't gotten it to her yet. So we'll figure that out. And then April 6th, we're going to have Kirsten Newcomer join us to talk about security and OpenShift. So
yeah, that's going to be really good.
Yep. So we'll figure out what we're talking about next week. Keep an eye on the calendar. Keep an eye on all the social media, and we'll publicize that. But yeah, thank you everybody for joining us. And Johnny, I'll leave you with the last word.
This was an awesome demonstration. I appreciate you guys coming on and doing this. This is exciting for me, and I know it's exciting for our customers out there. So keep up the great work, and we'll see you around.
Thank you. Bye-bye.
Thank you.
Bye now. Have a good